You are listening to The Vocal Technologist. Spoken tech for your ears.
I swear, every Monday morning, it's just the amount of news in tech, especially around AI and infrastructure, it feels like trying to drink from a fire hose.
Oh, absolutely. It's relentless.
We're not just, tweaking things anymore. It feels like fundamental practices are being completely rewritten almost week by week.
It's true. And if you kind of step back from all the individual announcements, you start to see these maybe 3 or 4 really big trends colliding.
Right.
It's a lot to take in, which is, well, why we're here.
Right.
To try and cut through some of that volume and connect the dots on the shifts that are actually changing how you work, like right now.
Exactly. Yeah. Our goal today is really to give you some context on the real structural changes happening. We're going to look at how AI is getting baked right into DevOps workflows and the frankly mind-boggling scale of the infrastructure needed to support all this.
Physical layer, yeah.
And then maybe counterintuitively, why we seem to be facing this necessary crisis around basic software quality, despite all the fancy new tools.
That's a crucial piece. Okay, where should we start?
Okay, let's kick off with maybe the most eye-catching trend, this whole idea of talking to our infrastructure.
Ah, yes. Natural language interfaces.
We're finally moving beyond writing endless config files. Yeah, HCL, I'm looking at you and sort of jumping straight to defining our intent.
And that's a huge cognitive leap, isn't it? Instead of the developer having to translate their idea into precise code,
Right.
you let the machine handle translating natural language into the actual infrastructure setup.
Spacelift Intent is a great example here. It's this new system where you can literally ask for cloud resources in plain English.
Not in, like, Terraform syntax or CloudFormation.
Exactly. But what's interesting is how they're doing it. It uses open standards, like OpenTofu, the Terraform fork.
Keeps it open.
And it seems to complement the traditional workflows. It's not necessarily a rip and replace, more like a better interface on top.
Which brings up the governance question, though.
Yeah.
If I'm just telling an LLM what I want, how do I make sure it's safe? How do I audit that?
That's the key. And that's where this Model Context Protocol, or MCP, comes in.
Right, the MCP.
Yeah.
It's like the safety layer. It ensures that even though you spoke your intent, the system enforces guardrails, maintains governance.
And crucially, lets you export the configuration that the AI generated.
Exactly. So a human can still review it, audit it, the AI assists, but you still have that final oversight. It's not magic.
It's that balance, isn't it? Ease versus control. And we're seeing that same push to remove friction right on the developer's machine, too, with things like integrated AI agents, like the Docker MCP Toolkit.
Yeah, this is all about killing context switching.
What do you mean?
Well, normally you'd ask an AI model something, it gives you code, then you have to copy it, paste it somewhere else, maybe run a query, jump over to Slack.
All those little manual steps.
Right. With this toolkit connecting something like Claude Code directly into your tools, the AI can actually do those things. It can run the database query itself, or create the GitHub issue, or send the Slack message.
Ah, so it closes the loop. The AI isn't just suggesting anymore, it's acting within your environment.
Precisely. It becomes more of an operator. And that shift is the so what here? You see companies like Atlassian building these AI native suites, right?
Like their software collection, yeah. Unifying RovoDev, Bitbucket, pipelines.
The whole point isn't just speed. It's about keeping the developer in flow, reducing those annoying interruptions, while also giving managers better metrics on how effective that AI help actually is.
Okay, so workflows are getting smoother, more integrated thanks to AI. But, like we touched on, all this relies on some serious foundational horsepower. We need to talk about the physical scale.
Oh, the scale is.
Yeah.
It's almost hard to comprehend the numbers coming out of the big cloud providers.
I was absolutely floored reading about Meta's network scaling. They've spent 10 years building out their Global Express backbone, the EBB, for regular data center traffic.
Standard stuff, relatively speaking.
But now they're saying the infrastructure for just one new AI backbone site pair, so just connecting 2 AI-focused data centers, is twice the size of the entire global backbone they built over the last decade.
Twice the size. For one link.
It's staggering. Think about that. It's not just adding a lane to the highway. It's like building a completely new double-decker superhighway just for AI traffic.
Which means totally different architectures, right?
Mm-hmm.
Changes to their DC metro designs, how they integrate IP and optical networking, just massive foundational shifts to handle the sheer bandwidth.
And once you have all that data flying around, you need to be able to find things in it. We talk a lot about RAG, retrieval augmented generation.
How AI checks its facts against your documents, basically.
Right. But RAG and semantic search, they can get totally bogged down by old, inflexible search systems.
Yeah, your AI is only as good as the data it can retrieve quickly. If that retrieval is slow, the whole experience suffers. That's why vector databases are suddenly so critical.
Like OpenSearch 3.0.
Exactly. They've introduced this next-gen vector engine specifically built for this. Fast, flexible, enterprise-scale vector search designed for these really high-volume AI workloads. It can even handle those complex hybrid queries, mixing keywords in vector search.
Okay, so the data's flowing, we can search it, but you also need to manage that flow, especially under pressure, to keep things stable. Let's talk traffic management.
This is a really neat example from Airbnb, actually. They have a key value store called Muscle.
Okay.
And like most people, they used to use static rate limiting. Just saying, allow X requests per second. Simple count.
Seems reasonable.
Until it's not. What if one of those requests suddenly uses way more resources? Or you get a hotkey that everyone hammers at once? Simple counting just falls apart.
Ah, right, because not all requests are equal.
Exactly.
Yeah.
So Airbnb realized counting requests was kind of pointless. They shifted to what they call adaptive traffic management. It's based on resource accounting.
So instead of counting requests, they measure the actual cost, CPU, memory, database load.
Precisely. And that let them build smarter controls. Resource-aware rate limiting, better load shedding during spikes, defenses against those hotkeys. The goal wasn't just limiting requests, it was maximizing good put.
Good put.
Yeah, the useful, successful traffic getting through, especially when things get chaotic, keeping the system stable and actually productive.
That focus on stability and control is a perfect segue into security and visibility.
Yeah.
Because if our infrastructure is becoming more dynamic, maybe even AI managed, our access controls have to keep up.
Oh, absolutely. Static SSH keys, they've been a known problem for, what, a decade?
Maybe longer.
They stick around forever, get shared, nobody rotates them.
Yeah.
Terrible for audits, key sprawl.
Total nightmare. But the industry is really moving towards SSH certificates now.
So instead of a key that lives forever, you get a temporary signed token from a central authority.
Exactly. Short-lived, cryptographically signed access. And tools like HashiCorp Vault or Boundary make this pretty seamless. They can dynamically generate and inject these temporary credentials. So SSH access stops being this lingering vulnerability and becomes a properly managed, auditable control point, which you absolutely need in modern setups.
Definitely. And you need similar zero-trust thinking around the AI workloads themselves, especially on Kubernetes.
Yeah.
The stakes are just higher sensitive data, powerful APIs, sometimes acting on their own.
So what does a zero-trust setup for AI on K8s look like?
Well, it's layered.
Yeah.
You start by securing the API endpoints, maybe using the Kubernetes Gateway API for smarter routing. Then you need strong network policies enforced by CNIs like Calico or Cilium to control traffic flow between components.
Okay.
You also have to lock down the API keys these AI systems use. Maybe restrict them by IP address or force their traffic through specific egress gateways. And of course,
observability. You have to see what's going on.
mandatory. If you can't see it, you can't secure it.
Mm.
Tools like Grafana Cloud are pushing this idea of interconnected observability,
Yeah.
meaning not treating logs, metrics, and traces as separate things. They're unifying them into layers, so you get this richer context automatically. Saves time, saves money. They even have AI assistants like Grafana Assistant to help find insights faster.
But, and this is a big but, even with all this amazing tech and AI assistance, there's still a crucial human element, isn't there?
There is. There's an observability survey recently. Fascinating result. It found that 69% of decisions based on AI insights are still verified by a human before action is taken.
Wow, 69%. So nearly 7 out of 10 times we trust the AI's analysis, but we still need a person to give the final okay.
Exactly. It tells you a lot about the current trust boundary. We're using the tools, but that final judgment call, it still rests with the experienced engineer.
That really sets up our final theme perfectly, because if we're making development easier with AI, scaling infrastructure like crazy, and getting better at dynamic security, why are we still seeing, billion-dollar outages treated as almost normal?
This software quality question.
Yeah. This discussion, maybe especially here on The Vocal Technologist, really brings it home. How much do we need to focus on software quality itself?
Well, there's some pretty stark data suggesting we're in maybe a great software quality collapse.
That sounds dramatic.
It is.
Yeah.
But the finding is basically that companies have chased speed, spent fortunes on infrastructure, layered on abstractions, often at the expense of just disciplined, solid engineering.
And the result is, what? Apps leaking memory? Like sieves?
Yeah, apps leaking gigabytes. Billion-dollar outages becoming almost expected. Fears about AI causing massive data loss. It feels like we're using amazing hardware and AI partly to paper over cracks in fundamental code quality.
So what's the fix? Go back to basics.
In many ways, yes. Simple discipline often helps enormously. Take Dox's code, or Dicey.
Okay.
The Squarespace domains team wrote about adopting this. They decided to treat their documentation, markdown files, mermaid diagrams, whatever exactly, like they treat their code.
Meaning it lives in Git, needs version control, requires pull request reviews.
Yeah.
Exactly. It lives right alongside the code it describes. It gets reviewed with the code changes.
Yeah.
That brings traceability, faster updates, and just basic engineering rigor to documentation, which often gets left behind.
That makes so much sense. If the docs need a PR, someone has to actually check them before they merge.
Right. Simple but effective.
Okay, and this leads to a really fascinating point you found about the people involved. The illegible nature of software development talent. What's that about?
It's this idea that if you look closely at really high-performing teams, some of the most critical engineers are almost invisible publicly.
How so?
They don't maintain flashy GitHub profiles. They aren't constantly posting hot takes online. They don't neatly fit into the rigid checkboxes that HR or standard performance reviews often use.
They're the quiet ones.
Often, yeah. They're the ones quietly doing the really hard, detailed work, writing the robust, maintainable code, performing the unglamorous but essential maintenance that actually prevents those billion-dollar outages. They keep things running smoothly.
But our systems hiring, promotions, they tend to reward the visible stuff.
Exactly. They favor what's legible, the commit count, the conference talk, the person who fits the rubric easily. And they often overlook the truly valuable contribution, that quiet, high-quality, preventative work that doesn't show up neatly on a dashboard until something breaks because that person left.
Wow. So the reward system might actually be undermining quality by prioritizing visibility over impact.
It's a real structural problem, yeah.
Yeah.
We're potentially optimizing for the wrong signals.
Okay, that's a lot to think about. Let's recap quickly. We've seen AI moving from just an assistant to more of an active operator in workflows.
Driven by things like natural language and integrated agents.
Supported by just unprecedented infrastructure scaling, which in turn demands next-gen search like vector databases and smarter adaptive traffic management.
Right, and security needing to be dynamic, ephemeral, certificate-based.
And finally, this huge looming question about software quality, the potential collapse, and how it connects back to fundamental discipline like Dox's code, and maybe even how we recognize and reward the quiet, high-impact engineers.
For me, the big takeaway is this tension. We're throwing incredible hardware and AI at complexity, but maybe the real fight is still against the simpler things. Undisciplined code and failing to value the people whose main contribution is preventing fires rather than fighting them.
That's a perfect place to leave it for today. We talked about how our systems tend to prioritize visible signals, the commits, the posts, the metrics. So here's something for you to think about. If the most impactful engineers on your team might be the quiet ones, the ones whose work prevents problems, how could you adjust your team's metrics, your rewards, your recognition right now to better capture the value of that often invisible, high-quality work?
Definitely something to mull over.
We'll see you next time.
Spoken Tech for your ears.